All right, we are on day 3, not that paper. We are doing the second half of chapter 6 today. So here we go. All right, second half of chapter 6. Tomorrow we start 7. We're graphing logs today and still working with logs, solving equations with logs. So here we go. Solve each equation, starting off right away. Okay. So here, the only way to solve this is to change it into logarithmic form. So I'm going to do, this is going to be my base, log base 10. This is my number that goes with the log, and it equals x minus 1, equals the exponent. So we talked about the BAE, base, answer, exponent yesterday. I wrote that down. So this means that since it's base 10, this is something that you can absolutely do in the calculator. Base 10 is the default base for logarithms, right? Like natural log, ln, the default base is e. So I, to isolate x, can add 1. Now, this log 25, you need to work that out because it is together, and then you're going to add 1 after. And this is on your calculator. So you press the button log 25 equals plus 1. Number 2, 20, number 2. Natural log, remember this is base e, right? We don't always put e. I don't put a 10 always next to the word log. But e to the 4th equals 2x plus 3. I'm isolating x, so you need to solve for x. And you'll use the calculator at the end. You can do number 2 on your own. We will look over the answers tomorrow. Okay, let's graph. 21. So I wrote a bunch of little tips over on the right. Log base whatever of 1 equals 0. Log base whatever, and the bases match, the base and the number matches, that equals 1. Natural log, the bases and the number match, that's 1. So these two are similar rules. Natural log of 1 equals 0. Logarithms have a vertical asymptote. My vertical asymptote is going to be the h. So vertical asymptote, x equals h. So that means that it's going to be a vertical line on the asymptote. So the way that the logarithm graph appears is not the same as yesterday's exponential. So what I would like is I'm going to look at my parentheses here, and I want, ideally, right? I want my parentheses, whatever's in parentheses, to equal, I want it to equal a 0. So I would plug in 0 for that. Or I want it to equal a 1. So that would mean I'd put like, maybe I could put log base 3 of 1. Or I want it to equal the base, to match the base. So I'm going to do just two of these for part A. Now, it's log base 3. So I could make it log base 3 of 1, because remember, log base whatever of 1 equals 0. So if I pick 1, I would get log base 3 of 1 plus 1. Log base 3 of 1, that equals 0 plus 1. 0, 0 plus 1. 1. So 1, 1 is an ordered pair on my log graph. I also would be thrilled if I could do the base. Like if it's base 3, then if I put a 3 in for x, then that means I'm gonna get log base 3 of 3 when the base and the number matches, that equals 1. So this will be log base 3 of 3. Make sure your plus sign, I should put it in parentheses. So let's do log base 3 of 3. 1 plus 1, 2. 3, 2. My vertical asymptote is h, which is 0. So it's going to be and my graph gets really close to my asymptote, but never touches, and then it continues on in both directions. Domain and range. So this time we didn't use the having my parentheses equal to 0. And on the next one, I'm not going to have it do that either. So let's do domain. Oh, okay. From left to right, nothing. It starts at 0. So it's going to be a parentheses because it's not included. And then it goes on to the right forever, comma, infinity. My range, up, down to up, small to high. Negative infinity, yep. Okay. And this does move upward slowly, up. So I can put negative infinity to positive infinity. It just takes a long time for it to get very high, but okay, my natural log graph. Same thing. I want this x minus 2 to equal the base, which is, remember, e equals 2. Let me move it aside. E equals 2.7. And I would want my x minus 2, my parentheses, to equal 1. That's from over here. So since it's natural log, if I want this parentheses to equal 2.7, something minus 2 equals 2.7. Something minus 2 equals 2.7. So I'm just going to solve 4.7. If I choose 4.7 to plug in for x, I will get natural log base e of 4.7 minus 2 equals natural log base e of 2.7. Oh, matching. Natural log and base e, numbers are the same, that equals 1. If I want my parentheses to equal 1, natural log base e 1, which look, natural log base e of 1 would give me a 0. Let's find out. Something minus 2 equals 1. That's easy. 3 minus 2 equals 1. So 3 is the number I'm going to plug in. Natural log base e of 3 minus 2. Natural log of 1. 0. My vertical asymptote is x equals h. Well, x minus 2, this opposite sign, remember how there's always the opposite sign in HK transformations, positive 2. So draw your vertical asymptote and graph your points. Over 4.7 up 1. Over 3 up nothing. There's my graph. Oh, domain and range, sorry. Domain, 2 and infinity. No negatives at 2, it's in parentheses, but then it goes on to the right forever and ever and ever. My range from low to high, negative infinity to positive infinity. And we're good. Okay. I'm going to go on to 20. Any questions? No one's really talking. Why is that? Okay. 22. I am given values for log base 5 because log base 5 is not something that we use often. And I can't do log base 5 in my calculator unless, and the only thing I can do in my calculator is log base 10. So, sorry, get all this gone. All right, so since I'm told log base 3, now remember the properties of exponents from algebra 1, it also applies to this 3 divided by 7, because this is really a subtract. Log base 5 of 3 minus log base 5, 7. And since I give you the decimal versions of that, you can subtract that in your calculator. Change these to the decimal versions and subtract. On part B, it's 21. Well, 21, how do I make 21 from 3 and 7? Multiply. Well, multiplication in our exponent and our logarithm rules is an addition. Log base 5 of 3 plus log base 5 of 7. So you're going to log base 5 of 3 plus log base 5 of 7. Change these to decimal versions and add. So some of these you're gonna have to do on your own. I did the graphs for you because I just wanted to really make sure it was solid, but look over your notes and then finish the ones I don't finish. I'm jumping to 23, I'll do 23, 24, 25. I'll do one from each question. So expand the following using properties of logs. Well, a multiplication, 2 times x to the 6 means I add. And an exponent of 6 means you move to the front. Let me show you what I mean. Log base 5 of 2 plus this, okay, so the 6 gets put in the front of log of x because it's 2 times x to the 6th. So remember the rule where the 6 got moved to the front? The exponent moves to the front. I did not give you any decimals. You can't go further. You stop there. I think you can do B by yourself.
Miss Grant, would it be 6 log base 5x or 6
Oh,
log
yeah, base 5. Sorry, it is base 5. Yeah. Yes. Change of base. Log, whatever, like m n. If you remember, it's the numerator is the large number, denominator. And these now change into base 10. A change of base means I can't do base 4 log. I can't calculate that. The only thing I can calculate is base 10. So if I change them to base 10 using the change of base formula, it means that the numerator is the larger number, the denominator is the little base. And when I write them, it's no longer base 4. It becomes base 10. I can do this in my calculator. So you will do that in your calculator and you'll get a decimal answer.
Miss Grant?
Yep.
Well, can you do the same thing with natural logs?
Yeah, yes, you can. Yeah.
Miss Grant,
B, I'm confident you can do. Oh, yeah.
would you change log 8 and log 4 to a decimal before dividing?
Yes. So you're gonna, don't change it to 2 because log base 10, 8 is its decimal. Log base 10 of 4 is a decimal. Then you divide. This does not say log base 2. This says log base 8, calculate it, figure it out, then calculate log base 4, and then divide these decimals. Okay, 25 has 4 parts. And you know what, honestly, A and B are the ones that I think are ones that I'd like to share to work with you. So we're gonna do A and B. You can do C and D for homework. Okay, the, oh no, this is just, I'm sorry, I was thinking 26. Okay. 25, I'll do A. Changing it. This I have no clue. 2 to the what equals 7? I don't know. So change to logs. This means that my log base 2 of 7 equals X. I can do change of base for this. So I'm just going to write that on the side. I can do change of base, log 7 divided by log 2.
Miss Grant,
Natural log, it's the same, you do it the same way, but I use ln because it's natural.
Miss Grant,
Yeah.
is there any instance where you can't use change of base?
Change of base is only when you're given a weird base and you have to evaluate something. So the format for change of base is this format, where log a weird base of a number. And this is the only format that you would use change of base for.
Okay,
It's
so
not
like,
like I can randomly go up here and do change of base for that because I know what the base is. It's E.
so you can always use change of base if you have a weird base, correct?
Right, and I'm trying to solve for X. That's a
Got
big one. I want to solve for some, I want to find the answer to that weird base.
Thank you.
Okay, so now I can go to 26. This is the one that I want to do A and B with you. So now I have, let's see, okay. All right. When I first look at it, I see, well, I've got 25 and 125. The bases don't match up. They're related because like 5 goes into them. So if I want the bases the same, I'm going to make the bases the same because I can't really do anything right now. 25 and 125. So 25 is 5 squared, but then it has an exponent, 2x plus a half. So I'm changing them both to have a exponent base of 5. 125 is 5 to the third, but there's an x there pre-existing, so I have to include that as well. Now that they're both the same base, set the exponents equal to each other. And solve for x. Okay, check out C. They're already got the same natural log of e. They already have the same base. So you just set them equal to each other. That's really easy. Part C is really easy. This, I know I'm going to have to use natural log. So let's first isolate before I take the natural log of both sides. Isolating means get the 6 gone. So now I'm going to take the natural log of both sides. Natural log of e to the negative x. Remember, this is base e, and hey, e, woo, natural log of 15. Since these match up, look, right here. This whole thing right here is 1. This right here is a 1. I write my exponent, that's all that's left. My right side I can't change because they don't have the same base and the number matching or a 1. So I keep my natural log of 15 on that side. But this is a calculator calculation. I have a button in my calculator for natural log. So let's just move the negative over. Negative natural log of 15. So that would be something on your calculator. Let's see. So you're going to do C and D on your own, calculate, finish solving A, finish solving B. The last lesson in chapter 6 is on geometric sequences and then the sum. So there's a formula, if I have a list of numbers and I'm trying to figure out, how are the numbers changing? What's the rule? And, what's the 5th term in this sequence? What's the 10th term in this sequence? All right. So, in order for me to find, first I'm going to write the rule. A sub 1, first term. The R is my ratio, how's it changing? So it's 48 to 24, what's happening? What am I multiplying by? I'm not dividing, it's always multiplication for sequences, adding something for series. So we're doing sequences right now. What am I multiplying by? Times what? To go from 48 to 24. What is it?
0.5.
A half. I'm going to just do a half or 0.5. And then 24 to 12, multiply by a half. So my first term, A sub 1. Man. My A sub 1 is 48. My common ratio is a half raised to the n minus 1. This is my rule. I have to know how the numbers are changing. I have to know my first term. And then find the 7th term. 7. I want to know 7, so it's just 7 minus 1. A sub 7, and you'll do this on your calculator, 48, 1/2 raised to the 7 minus 1 power. 48, and then obviously the 1/2 is 6. 1/2 to the 6th power goes first, and then you multiply it by 48. That's how 1/2 raised to the 6th power, first in your calculator, then times 48. And then that'll give you your 7th term. So you can work this out on your own. Last problem is going to be the sum of a series. And this is sigma, remember the Greek alphabet letter? A sub 1 is still my first term. R is how it's changing. This, okay, ready? I start out at 1. This is going to be 5 terms. This is my rule. 4 times 2 raised to the however minus 1. So this formula here, you're going to do a sub 1, my first term is 4, right? A sub 1 is 4. And then I do 1 minus r, my rule, to the n, 5th. But I want you to do it on your own. Finally indicated sum. I don't need the word terms there. Okay, well, let me stop the recording first. And then I can answer questions.